Is your trading strategy robust or just one lucky setting? A backtest can look excellent because one stop, target, or entry rule happens to flatter one market window. Move that setting slightly, and profit may shrink while drawdown worsens. If only the exact recipe works, you may have tuned to noise instead of finding a durable relationship. Parramatta neighborhood testing asks whether nearby sensible settings form a broad plateau or whether the result stands on a narrow peak beside a cliff. First, name the knobs. A stop is the price distance where a losing trade closes. A target is the price distance where a winning trade is taken. An entry parameter might be an hour, look back, or indicator level that decides whether a trade begins. A parameter neighborhood is a small grid of nearby, sensible versions of those choices. The frozen baseline is the original setting replay under the same market history and rules. It anchors comparison. It is not a trade list that every cell must reproduce. The procedure is deterministic. Freeze the candidate, historical bars, test window, market context, cost assumptions, and replay rules. We do not start from one finished trade list and remove or shuffle its trades. We replay the same historical bars under each nearby setting, so the trades that result can still change. A tighter stop can exit earlier, a different target can close later, or never trigger. Trade order Monte Carlo begins with an existing ledger and reorders or resamples completed outcomes. That is a different question from changing strategy settings and replaying the bars. Here is a concrete sensitivity example. Imagine an entry at 100, an original stop at 99, and a target at 102. The price dips to 98.95, then rallies to 102. A stop at 99 closes the trade. A slightly wider stop at 98.80 survives and may reach the target. A tighter stop at 99.10 exits sooner. Change the target to 102.20 and the winner may disappear again. The bars stayed fixed, but the resulting trade path changed. Repeating that operation across nearby stop and target choices creates the map. Read the flat map before the terrain. Left to right is the stop multiplier. Bottom to top is the target multiplier. Each cell shows a risk-adjusted result. Net profit divided by the worst drawdown endured. The original setting replay is outlined as the baseline. A broad plateau means many neighbors remain reasonably similar, even if the center is not the highest point. A narrow spike says the attractive result depends on precision. A cliff shows the direction where one small change causes a large deterioration. The three-dimensional view makes that shape easier to inspect. Height and color encode the same risk-adjusted result, while perspective reveals ridges and sudden drops. But do not stop at the summit. The lower tail distribution asks how the weaker tested cells behaved. Its fifth percentile is the level below which roughly 5% of cells fall. If that weak tail remains near the baseline, the neighborhood is steadier. If it drops sharply, the peak hides fragile neighbors. Ranked bars identify which settings caused the damage. Then inspect the path behind the score. Two cells can finish with similar net profit, yet deserve different interpretations. If one equity path suffers a much deeper drawdown before recovering, its risk-adjusted result is lower. Matched equity and drawdown panels show whether weakness came from less profit, more pain, or both. In this local implementation, nearby stop and target values use 5 scales from 0.70 to 1.30 and a fifth percentile to Baslane ratio of 0.50 is one local rule, not a universal law, confidence level, or deployment permission. A common misuse is to inspect the surface, choose the brightest cell, and announce robustness. That is optimization after looking, not evidence that the original choice was stable. Another misuse is widening the neighborhood or changing its boundaries until a plateau appears. Large surfaces may use a fixed sample of coordinates, show tested coverage as n out of n, leave untested cells empty, and never smooth gaps into a continuous landscape. A fragile sampled pocket is a warning. A clean sample is only partial reassurance because missing cells remain unknown. So why does neighborhood stability matter? It reduces dependence on one exact research choice and makes a noise-mined winner easier to recognize. It still does not forecast a new regime, prove live fills, or capacity, erase selection bias, or authorize deployment. The same historical window can reward many nearby settings for a reason that later disappears. Next evidence must include trading cost stress, trade sequence testing, and forward movement through unseen time. Treat a plateau as one stronger piece of evidence, then ask what could still break it.